17 years ago, China had 0 kilometers of high-speed rail. Nothing. By 2025, it is set to operate 46,000 kilometers, beating every other country on Earth combined and seizing 70% of the global network. This is more than a construction boom. It is the fastest infrastructure leap in history, outpacing pioneers like Japan's Shinkansen and France's TGV in a fraction of the time. While the rest of the world barely reaches 20,000 kilometers after decades of effort, China's meteoric rise demands a simple question. How did a latecomer outsmart everyone and completely rewrite the rules of high-speed rail? The answers reveal a strategy and its consequences that almost nobody saw coming. China's high-speed rail network didn't just surpass the world, it redefined what's possible. In 2007, the country's high-speed mileage stood at 0, not a single kilometer. By 2025, the figure rockets to 46,000 kilometers. That's nearly triple the combined total of every other country on Earth. 70% of all high-speed rail lines running through one nation. In less than 2 decades, China built a network longer than the distance from New York to Los Angeles, coast to coast, 10 times over. On a map, the transformation looks unreal. An empty canvas in 2007, then a dense web of lines stretching from Beijing to Kunming, Shanghai to Urumqi, connecting almost every major city. No other country comes close. Japan's Shinkansen, the original pioneer, took 50 years to reach 3,000 kilometers. France's TGV, after 4 decades, clocks in at just over 2,700 kilometers. The United States, for all its industrial might, hasn't built a single true high-speed rail corridor. Meanwhile, China's network expands by thousands of kilometers each year. It's not just about tracks and trains. This scale means 16 million passengers move daily at speeds that once seemed futuristic, over 300 kilometers per hour. The rest of the world, combined, struggles to reach even half of China's total mileage. For governments, engineers, and business leaders everywhere, the numbers are almost unthinkable. How did a country with no high-speed tradition leapfrog the world in less than a generation? To answer that, you have to look back, before the first track was ever laid. In 1964, Japan launched the Shinkansen, the world's first high-speed rail line. Trains raced between Tokyo and Osaka at 210 kilometers per hour, a speed that seemed almost impossible at the time. 17 years later, France introduced the TGV. The French trains not only challenged the Shinkansen's records, but also set new standards for comfort and reliability, pushing speeds up to 260 kilometers per hour. By 1991, Germany joined the race with the ICE, blending cutting-edge engineering with the country's reputation for precision. Each of these systems transformed national travel and became symbols of technological pride. While Europe and Japan were building high-speed corridors, China's railways remained rooted in the past. Through the late 1990s and early 2000s, China's fastest trains topped out at 160 kilometers per hour, barely half the speed of the Shinkansen, and far behind the TGV. Overcrowding and delays were common, especially on the country's aging conventional lines. Chinese planners recognized the gap. In 2004, the government unveiled the medium to long-term railway plan. The goal? Build 12,000 kilometers of high-speed rail by 2020. At the time, this sounded wildly ambitious. No other country had attempted a leap of this scale, especially starting from a network with 0 high-speed lines. But for China, the challenge wasn't just about catching up. It was about leapfrogging decades of incremental upgrades and adopting the best the world had to offer, all at once. The global context was clear. High-speed rail had matured in Japan, France, and Germany, but remained limited in reach. China, facing a massive population and growing cities, saw an opening. The question wasn't whether to build high-speed rail. It was how to do it faster, bigger, and more efficiently than anyone had before. Foreign train makers arrived in Beijing with their best engineers and thick binders of blueprints. But the rules of the game were different here. The Ministry of Railways issued a clear ultimatum. Access to China's vast market required handing over the technology behind the trains. No transfer, no deal. Siemens, Kawasaki, Alstom, and CAF all faced the same choice. Want access to 1.4 billion customers? Share your crown jewels first. That was the message, repeated in negotiation rooms and written into joint venture contracts. Each partnership came with strings attached. Siemens brought the Velaro platform, which became the CRH-3. Kawasaki's E2-1000 Shinkansen technology became the CRH-2. Bombardier's Regina trains, through Canadian and Swedish connections, formed the basis for the CRH-1. Alstom's TGV and Spain's Talgo designs were also folded into the mix. The contracts didn't just cover finished trains. They included full technical data packages, blueprints, source code, manufacturing processes, even detailed instructions for supplier qualification and maintenance. Chinese engineers worked side by side with their foreign counterparts, absorbing every detail, sometimes requesting extra documentation or clarification on proprietary systems. Inside the joint ventures, foreign engineers found themselves training the people who would soon replace them. Internal memos from Siemens and Kawasaki later described the experience as teaching our replacements. By 2010, China had fully internalized these foreign designs. The CRH-380 series, faster, sleeker, and more reliable, was already rolling out. What had taken Japan, Germany, and France decades to develop, China compressed into a few years. The toolbox was now Chinese. Every component, every system, ready to be scaled up for a nationwide build-out. Money poured in at a pace rarely seen in infrastructure history. In 2008, China committed $49.4 billion to high-speed rail, more than the annual GDP of some countries. The next year, that figure soared to $88 billion, as the government doubled down on stimulus spending and national planners raced to break ground on new lines. Construction sites stretched from the industrial northeast to the subtropical south, with thousands of workers laying track, building viaducts, and wiring up advanced signaling systems, often around the clock. The Beijing-Tianjin Intercity Railway opened in August 2008, offering a glimpse of what was possible. 350 kilometers per hour, slashing the journey between two megacities to just 30 minutes. Engineers and planners saw this as proof of concept. Within 16 months, the Wuhan-Guangzhou line shattered expectations, setting a world average speed record, 312.5 kilometers per hour over nearly 1,100 kilometers. What used to be a 10-hour slog became a 3-hour dash, connecting central China's heartland with the booming south. By June 2011, the Beijing-Shanghai route was in service, built for 380 kilometers per hour and linking the country's two largest cities with a level of frequency and reliability that rivaled air travel. In just 3 years, China's high-speed network ballooned from a handful of demonstration lines to the world's longest, crossing the 8,358-kilometer mark by January 2011. Planners boasted of a new line opening every month. For a moment, the possibilities felt limitless. Each ribbon-cutting ceremony celebrated as a victory for speed, scale, and national ambition. Then came the crash that shook the entire high-speed rail project to its core. On July 23, 2011, 2 trains collided outside Wenzhou, plunging carriages off a viaduct in the rain. 40 people lost their lives. Hundreds more were injured. The official response was swift and secretive. Rescue operations halted after a few hours. Railway officials ordered a crushed carriage buried on site, sparking outrage across social media. Survivor accounts described confusion and delays. Dispatch logs later revealed that emergency services were kept waiting while officials arrived first, scrambling to control the narrative. Online posts and photos vanished almost as soon as they appeared. For a brief moment, public anger forced authorities to loosen internet controls, but the damage was done. The Wenzhou disaster exposed more than a technical flaw. Behind the scenes, investigators uncovered a web of corruption that reached the highest levels. Liu Zhijun, the powerful Minister of Railways, had accepted over 1 billion yuan in bribes across a decade. His deputy, Zhang Shuguang, misappropriated $2.8 billion. Contracts, procurement, and safety oversight were all tainted. The system that built the world's fastest trains had also cut corners, rewarded loyalty over competence, and ignored warning signs. In the aftermath, China's high-speed rail ambitions slammed on the brakes. Trains were ordered to slow from 380 kilometers per hour to 300. Projects worth 1 trillion yuan were paused overnight. Audits swept the network, and for the first time, the world saw the risks hidden beneath the glossy headlines. The promise of speed and scale now faced a reckoning, one that would test whether the system could reform and regain the public's trust. China's high-speed rail network is not just the world's largest, it's also the cheapest to build by a wide margin. Track for track, Chinese high-speed rail costs between $17 and $25 million per kilometer. In Europe, the same stretch of rail can run $25 to $40 million. The difference isn't just about cheaper labor or materials. China sidestepped one of the biggest line items: land. State ownership meant farmland and city plots could be acquired at official rates, often far below commercial value. There were no lengthy negotiations, no courtroom battles with private landowners. That alone slashed upfront costs by as much as 80% in some regions. Financing played its part too. Policy banks like China Development Bank and Exim Bank supplied long-term, low-interest loans, backed by government guarantees. Local governments created special purpose vehicles to handle land and station development, sometimes offsetting costs with future real estate profits. And by forcing foreign partners to share blueprints and technical know-how, China saved an estimated $50 billion in research and development, compressing decades of trial and error into a few years. The result? A network built at a price point that competitors struggle to match, with cost savings that ripple into export bids and global contracts. 10,000 high-speed trains run across China every day, moving 16 million people, more than the population of some countries, at speeds that rival jetliners. The technology behind these trains is no longer borrowed. It has been pushed to new extremes by teams of CRRC engineers and research chiefs determined to set records. The CRH-380D set the bar at 380 kilometers per hour in regular service, but the latest Fuxing model, the CR-450AF, has already reached 420 kilometers per hour in testing. That's faster than any commercial train in the world. The scale is just as impressive as the speed. By 2025, China's network covers 97% of cities with more than 500,000 residents. The next target? 60,000 kilometers of high-speed rail by 2030, stretching to 70,000 by 2035, enough to circle the globe nearly twice. Meanwhile, prototype maglev trains have topped 600 kilometers per hour on test tracks, hinting at a future where even the fastest bullet trains look slow. For China's rail engineers, the ambition is clear: keep breaking records, keep connecting cities, and make high-speed rail the backbone of national life. In 2015, Indonesia stunned the rail world by awarding its first high-speed line to China, not Japan. The Jakarta to Bandung contract went to Chinese builders on a bid over $1 billion cheaper than Tokyo's, with financing terms that left Indonesian officials breathing easier. No government guarantees, just a low-interest loan from China Development Bank, a 10-year grace period, and a promise to deliver the 142-kilometer line at 350 kilometers per hour. Cabinet records show cost wasn't the only factor. China offered a full technology transfer, rapid build-out, and political backing through the Belt and Road Initiative. That playbook isn't unique to Southeast Asia. Chinese high-speed rail now stretches across borders. Turkey, Laos, Kenya, Serbia, and more than 60 countries have signed on for everything from rolling stock to turnkey systems. Annual rail exports top $7 billion, powered by contracts that bundle construction, equipment, and training. In less than a decade, China flipped the script, moving from technology importer to global supplier. The student now sets the terms for the world's newest high-speed corridors. 6 routes. Out of thousands of kilometers of track, only 6 high-speed lines in China have ever turned a profit. The Beijing-Shanghai corridor stands alone, generating more than $1 billion a year. Everywhere else, the numbers tell a different story. Debt tied to the network now tops $500 billion. National audits reveal losses piling up. Hundreds of stations see more staff than passengers. Internal reports from 2024 show some lines losing over 100 billion yuan in just 9 months. For Lu Dadao, a senior academic at the Chinese Academy of Sciences, the warning is blunt. The expansion is unprecedented, but so is the risk of massive overbuilding. The promise of cheap, fast travel comes with a bill that keeps growing, and the question of financial sustainability refuses to go away. Siemens once dominated the global high-speed rail market, but after transferring its Velaro technology to China, the company found itself locked out of the world's largest high-speed rail market almost overnight. Internal reports from the 2010s describe a sharp decline in new orders, forcing Siemens to pivot, first toward service contracts inside China, then to joint ventures for overseas projects, often partnering with former rivals. Kawasaki, whose Shinkansen blueprints helped launch the CRH2, faced a similar fate. By 2015, Chinese contracts had all but vanished, and Kawasaki's high-speed rail business was reduced to premium domestic lines and a handful of niche export projects. The response in Europe has been sweeping. The European Union approved a €100 billion rail investment plan, aiming to modernize and unify the continent's fragmented networks. Meanwhile, CRRC's Fuxing trains now outpace their German and Japanese ancestors, both in speed and technical reliability. The balance of power in rail technology has shifted, and the old champions are scrambling to keep up. Across the Pacific, the American story reads very differently. The United States, birthplace of the Transcontinental Railroad, now has 0 kilometers of true high-speed rail in operation. The closest attempt, the California High-Speed Rail Project, has become a cautionary tale. Initial plans called for a line connecting San Francisco and Los Angeles, less than 800 kilometers apart. The estimated cost? $100 billion, with no completion date in sight. That's more than 5 times the per-kilometer price of China's most expensive routes. Planners in Sacramento and Washington face endless hurdles: land acquisition battles, environmental lawsuits, shifting political winds, and a deep-rooted car culture. Maps of the U.S. show a patchwork of proposals, but no completed network. For American commuters, high-speed rail remains a promise, not a reality, highlighting just how far the gap has grown between the world's largest economies. In 2007, China had 0 kilometers of high-speed rail. By 2025, it will operate 46,000 kilometers, over 70% of the world's network. This transformation, achieved in just 17 years, relied on state-driven planning, aggressive technology transfer, and record-setting construction speeds. Foreign blueprints from Siemens, Kawasaki, and Alstom became the backbone for China's CRH and Fuxing trains, helping the country leapfrog decades of research and development. Yet, the story includes setbacks: the 2011 corruption scandal, the Wenzhou crash, and a rail debt now estimated above $500 billion. Today, only a handful of routes are profitable, while most operate at a loss. Some financial data and internal debates remain undisclosed, particularly on long-term sustainability. Still, China's high-speed rail has reshaped global infrastructure, upended traditional suppliers, and become a tool of economic influence. As of now, no other nation has matched this scale or pace. The documented facts show a model that changed the world and continues to challenge how nations build, compete, and connect.